In this video, we're going to talk about the axis of symmetry in quadratic functions. The axis of symmetry is the vertical line that goes through the vertex of a parabola. Remember, a vertical line has an undefined slope, and the equation is x equals the x-intercept, or the x value of any point on the line. Points on the parabola with the same y value will be equidistant to the axis of symmetry. So let me show you what I mean by that. So in this parabola, y equals x squared minus 2x plus 2, I have it graphed here. So the axis of symmetry is this line right here, which is the equation x equals 1. Because every point on this axis of symmetry has an x value of 1. So the axis of symmetry is x equals 1. So what I was talking about, the points being equidistant, so for instance, look at this line right here. So this point and this point, they both have a y value of 5. This is the point 3, 5, and this is the point -1, 5. So they have the same y value. And what you will see is that they are the same distance away from that blue line. They are both 2 units away from the axis of symmetry. They have the same y value. Same thing with these points down here. That is the point 2, 2, and this is the point 0, 2. Again, the same y value. They are both 1 unit away from the axis of symmetry. Now, in a quadratic function, if the parabola crosses the x-axis, those are called zeros or solutions. We'll talk more about that later. But the x-intercepts, which is what those points are, the points when the parabola crosses the x-axis, the x-intercepts will always be equidistant to the vertex. Why? Because an x-intercept is when y equals 0. So the x-intercepts have the same y value. Therefore, the x-intercepts will be equidistant to the axis of symmetry. So here is an application of that. So let's say that I know the 2 points, but I don't know the equation and I don't know the axis of symmetry. So let's look at these 2 points right here. So that one is the point 4, 10, and this is the point -2, 10. And so if I want to find the axis of symmetry, all I need to think about is what number is in the middle of -2 and 4. So from -2 to 4 is 6, the distance is 6 spaces. So halfway is going to be 3 spaces. So -2 plus 3 is 1. Therefore, the axis of symmetry will be at x equals 1. Again, if you know the x-intercepts, you can find the axis of symmetry even if you don't know what the equation is or you don't see the graph. You just have to find the halfway mark. Now, to find the axis of symmetry from standard form, all you need to do is plug it into this formula. X equals -b over 2a. So using our example from above, b is -2 and a is 1. So I'm going to plug that in. So x equals -2 over 2 times 1, which is 2 over 2, which is 1. So the axis of symmetry is 1. To find the axis of symmetry from vertex form, okay, so this is vertex form, y equals a parentheses x minus h to the 2nd power plus k. And in this form, the vertex, this is why it's called vertex form, is h comma k. So example, y equals negative 1 times x minus 3 squared minus 2. In that example, the vertex is 3, negative 2. Now notice it's a little confusing because in the formula it says x minus 3. But notice that h is the x value of the vertex. So if it says x minus 3, then 3 is the x value of the vertex. If it says x plus 3, then the x value would actually be negative 3. So you're taking the opposite of the sign that's in the parentheses. But the k is just going to be negative 2. Okay? Now remember, the axis of symmetry goes through the vertex. So the axis of symmetry here would be 3. Okay, so notice I wrote x equals h. That's your axis of symmetry because, again, it's just the x value of the vertex. You do not need to know how to write an equation in vertex form, but you do need to understand what the h and the k represent and how to find the axis of symmetry from that. Remember, the axis of symmetry goes through the vertex, so you can find the vertex by plugging in the axis of symmetry for x to find y. So let's find the axis of symmetry here. X equals negative b over 2a. Again, b is 6 and a is negative 1. So x equals negative 6 over 2 times negative 1, which is negative 6 over negative 2, which is 3. So the axis of symmetry is 3. Okay, so if I just kind of sketch a graph here, that means the middle of the parabola is right there. Okay, at x equals 3. So my parabola is going to be symmetrical about that line. So now I want to find exactly where the vertex is. So I am going to substitute this 3 in for here and here to find y. So y equals negative, notice how I plug this in, 3 squared plus 6 times 3 minus 4. So 3 squared is 9. So this is negative 9 plus 18 minus 4. I'm going to rewrite this. Negative 9 plus 18 is 9, minus 4 is 5. So the vertex is 3, 5. So the vertex would be right there. And we notice that the coefficient of x squared is negative. So we know that it's going to open down like this. Okay? So that is an overview of axis of symmetry and how you can use it to analyze different parts of a quadratic or possibly find more points on a quadratic function. And again, also using the axis of symmetry to find the vertex or vice versa. They are very much related.